So first let's open dev C++, control N to new file. Okay, so there are mainly two ways, static and dynamic. First let's try to write the static code. So hashtag include studio.h integer, or just let's do main function. Okay, now we have this. Now first for static, it's nothing but it is the same. Okay, basically no matter how many times we run the code, the output will always be the same. Dynamic simply means we can dynamically update this, aka we as the user we give this. So for static we give like so, int n is equal to 10, but if we want it to be dynamic, we just take int n, we say printf, okay, enter a number, then we do scanf, okay, to take the input, string %t comma address of n. Okay, because the variable is n, we take n address to give the location of the first chamber, %t because it is an integer. Okay, now the condition we can use are there. Mainly I would say like to use two conditions. The first simple condition is we simply divide it with 2 and check the remainder, and when that remainder is 0, it is an even number. So this is an even number. Okay, and in case it isn't a 0, when we divide with 2, there are only two possible reminders, that is 0 and 1. For 0 we know it is even, so the only another condition possible, it is odd, so we can just do that odd. Okay, so now just save it, control S to save. Let's call this even or odd. Okay, now F11 to run, and here, so 4 is an even number as we know, and then let's run it again, and 5 is an odd number. See, simple as that. Okay, and second, another one we can do is something called Anderson, and Anderson 1 is equal to 1, then it is an odd number. If it's 0, it is an even number. So we can also try this. So 4, it's an odd. Okay, so equal to 1 should be even, I guess. So 4, wait, so we'll make this even and we'll make this odd, and this should now work. Okay, so when it's 4, it's even. Okay, and let us say when it's like 7, it's odd. Simple. As you can see, these are the two ways we can write a code. Let me just here, and this should be modulus of 2. So if you're wondering what is the mechanism behind this, it is also very quite simple. Now how this works is, first let us take an example. For example, n equals to 4. Okay, now this n modulus 2 we can simply say as when n is divided by 2, we have to find the remainder of this. So n divided by 2, here we know n is 4. So what happens is we can use this division mechanism. So we'll write 4 here, we have 2 here, 2 2s are 4 and 0. As you can see, the remainder is 0. Again, we won't use any points, so we don't do like 2.10 or 2.5, no points here. Okay, just a plain old number, and here we have to see the remainder. For example, let us take 7, one of the previous example, 2, so we know 2 3s is 6, and we get 1. Here 1 is the remainder, and as you can see, 7 is an odd number which is not divisible by 2, hence gives us 1 as the remainder. 4 is an even number divisible by 2, hence give 0 as an remainder. So this is a simple way we can use modulus with the help of remainder we can calculate. So as you can see, when we have 1, it is an odd. If you want, we can also switch this simply by here making this 0. We can write even over here and odd over here. Okay, now how does this equation works? Okay, we know how the logic works. Now how exactly does the equation work? This equation, that is very simple. First we can split it by n percentage 2 as 1 bit equal to as 1 bit and 1 as another bit. Now what is the result of here? Can be 0 or 1. So when 0 equal to 1 is one case, 1 equal to 1 is one case. This gives us a boolean output, nothing but a true or false value. Okay, so when 0 equal to 1, it's false, hence it gives us false value, and 1 equal to 1 is true, hence gives us a true value. Now this is what will be executed here when we know if condition is true. Okay, the if block will be executed. Okay, that is from this bracket to this bracket, the if block. This if block will be executed, this entire thing, whatever is inside. Okay, here I have just written a single print statement, but there can be multiple things inside. Okay, in the case this condition fails, like here the output is 0 equal to 1. Okay, then the else block, that is from here to here, will be executed, and that is how this works. If you are wondering how the Anderson logic works, it is based on the binary logic. We have generally two types of logical operators. One is which we call bitwise operator, that go like and or. Another are and or. The difference is these and work for boolean values, so true or false, this is what we get. But this and or can also work as the and or operator for binary numbers. For example, for and we have a and gate call where only if 1 and 1 we get 0. If we have 0 and a 1, 1 and a 0, or zeros, sorry, only 1 and 1 gives us 1 for and. Rest all cases like this, it gives us 0. So using this and binary, we have a simple logic where, for example, if we take the first, let's say 4 numbers in binary, so 1 2 3 4, so 1 will be 0 0 1, 2 will be 0 1 0, 3 will be 0 1 1, 4 will be 1 0 0. In case you wonder how binary works, it has power like 2 power 0, 2 power 1, 2 power 2. So this is 1, this is 2, this is 4, this is 8, 16, and so on. If you observe, all these numbers are even numbers. There is only one odd number, that is this 1. This is the only odd number, and depending on this number we know if it's an even or odd. If you observe, only when the first unit digit is 1, the number is an odd number. If the unit digit is 0, it is an even number. As you can see, 1, it's an odd number, 0, it's an even number. This is a simple logic. So when we use AND operator, so let's say 0 0 1, 0 1 0, 0 1 1, and 1 1 1. Okay, as we know, only when there are two ones we have a 1. Here for 1 and 3 we have a 1 1, we get a 1, and here a 1 1, we get a 1. In remaining cases, if we have nothing, it is a 0. But if we observe, we know this all is 0. If this all is 0, regardless of here whether it be 0 or 1, we get the output as zeros. So this all will be filled with zeros. This is an even number. Since we don't have a 0 and a 1, it will be also 0. Okay, so using this AND operator, we can check the binary values of this number using that we know whether it's even or odd. This is a binary way to check. Okay, so either we can use modulus, which is just some math, or we can use the binary way, which is also just some maths. Okay, so the modulus checks for the remainder. Binary, simply we just check the last digit, since 1 is odd and 0 is even. Okay, so another trick you can generally follow with modulus is, for example, if you do n percentage, let's say x, the only possible output for this are 0 to x minus 1. For example, n modulus 4, the only possible outputs are 0, 1, 2 and 3. N modulus 5, the only possible outputs are 0, 1, 2, 3 and 4. For n modulus 2, outputs are 0 and 1. 0 is for even, 1 is for odd, and that is how it can be done. Okay, now let us try to write the same code in Python also. Okay, let's go with PyCharm. Okay, so in C we took n equals to 10 in this way if it's static. If you want to make it dynamic, for Python we take int function of input. If you remember, I have covered in previous video that input gives the output as a string. We have to convert it into an integer to do any mathematical operation. Now here we do n. In Python there is no requirement to always use brackets, but if you want you can use them. So I just go n percentage 2 equal to 0 colon, and here is the confusing bit. You just enter and make sure you have a tab space here. Here you can just write print, and when it's 0 we know it's even. Now when you press enter again, just to be clear, when you maintain this same row, okay, when you maintain a same row, this all comes under the if block. Okay, this is called indentation. This is how coding works in Python. In C, Java we use brackets, but for Python we use indentation. So if you even, let's say, want to add another print statement, you can add here, but even if you misalign it by single space or make it come previous by a single space, it will give an error. Make sure you keep it uniform, and for our clarity's sake, make sure you give a tab space or nothing but 4 spaces. Okay, and second, when you're coming to the else block, make sure it is parallel to the if block. If you write here, it goes inside the if block. We have to write it exactly below the if block, like so. Else, as you can see, it is exactly I and E are exactly under each other. Now enter print odd. Okay, now you can just run this. So for even, let me give some input strings, so like enter and run 5 odd, 4 odd. You can also kind of try the same logic. Anderson of 1 equal to 0, so 4 should be even and 5 should be odd. So yeah, the same logic works in Python also, and this is how you can code the even or odd number code.